Hello, welcome back to the Vintage Model Company. Today we've got the Cub setup video so that you can set up your Cub ready for flying. So after you've finished building the Cub, of course there are a few pre-flight checks that you'll have to do, such as the control direction, positioning your battery, and making sure that the plane is in balance. So what we'll do is just run through all of that, and then we'll get up in the sky. I'll sort of talk you through what I'm doing, and then hopefully that will help you have more success when you come to fly yours.
Now this video is going to be in sort of two segments really. There's going to be at the field, and then there's going to be here in the studio sort of setting up the plane ready for flight. Now understandably, once you finish your plane, you might want to just simply run outside straight away, chuck it in the air and fly it around. But just like a real aeroplane, if you imagine just sort of jumping into a real Cub with zero experience and trying to fly that, it's probably going to end in disaster. Going through these simple procedures before your first flight will increase your chances of success. The good news is that the Cub is a fantastic trainer for first timers and for people who have zero experience. So you can really learn and teach yourself everything that you need to know about flying RC planes with this plane. Now the first thing that we need to do is to remove the propeller, because propellers are dangerous and we don't want the possibility of accidentally chopping our fingers off. The probability of doing that at this early stage while you're messing around with the setup is increased somewhat. So yeah, we're just going to take this off now. If you're in the UK, you have to label your plane with your Civil Aviation Authority pilot registration number. To get your registration number, you can sit an online competency test that you can do through the BMFA website and other places. You must carry this number on your aeroplane, such as under a hatch or on the tail or somewhere that is clearly visible or accessible. And this is a measure that's been brought in to just make people a bit more responsible for their aircraft. Which is a bit controversial, but yeah, it's just one of those things. So there's more information on this in the description. Obviously it depends on what country you're in. Germany has a similar system, I believe. America is different again. These rules apply to aircraft that are over 250 grams, and unfortunately the Cub falls into this bracket as it's around 500 and something, so with the battery all loaded up. Alright, the next thing that we need to do is to check the centre of gravity. Now the centre of gravity on all of these Balsa Basics planes is found by putting your fingers underneath the main spar in the wing. What we're going to do is grab the flight battery, the one that we recommend, and stick it underneath the cowling here. So you should have a strip of Velcro under here, just to hold the battery on. And now we can put our fingers underneath the spar again to see if it's in balance and to see if this is nice and level. Now the reason that the centre of gravity is so important on aeroplanes is to do with where the lift is and where that corresponds to this pivoting point which is the centre of gravity, which all of the control surfaces make the aeroplane pivot around to control it. If you were to imagine that there's a lifting force, a central point of lifting force on the wing here, it would be found over this sort of area of the wing, which is around the main spar, the thickest part of the airfoil. You want this centre of gravity pivoting point to be in line with the centre of lift. If the centre of gravity was too far back and the plane was pivoting around this point here, the plane would be hopelessly unstable. Nose-heavy planes are slightly more stable but just fly poorly, so maybe to be on the side of caution, make your plane a little bit more nose-heavy than tail-heavy on your first flight. So that is to say, bring your battery quite far forward just to make sure that it definitely isn't tail-heavy, because yeah, you're going to have more success with a nose-heavy plane than a tail-heavy plane, suffice to say. There is going to be a bit of repetition in this video because we're going to be doing this at the field as well, but that's because you should be doing that too. You should be setting up the plane before you go out and then checking it when you get to the field. Okay, now I know that the centre of gravity is in the right place, I'm going to check the control direction of the tail feathers to see if we're going to be able to control the plane correctly. So we're going to take off the rubber bands on this wing to start with, just because we can access the servos on the inside of the plane a little bit easier by doing this. Now I'm going to grab my transmitter. So I'm going to turn the radio on, and then I'm going to stick the XT60 connector from the battery into the XT60 connector on the ESC. The plane is happy. Now again, we're going to be doing this at the field, so you'll see this again in a minute. But just quickly, just to check that we have got everything in the right order on the receiver here, in the right channels. I'm going to just cycle the controls and see if everything's working. So I'm going to pull up on the stick here, and the elevator is going to come up to meet it, so that's good. And then I'm going to go right on the stick, and it's got a tail wheel on this plane, so it wants to wheel around, but it's, yeah, so that's going right, that's going left, so up, down, left and right, yeah, perfect. Now I'm going to check to see that the throws, or the amount of travel on the control surfaces, is correct. On this plane, obviously it's a trainer, so you don't want it to be going to extremes, because we're not going to be doing 3D aerobatics. But yeah, we want to just check to see that they're not moving too much or too little. Now a good way to do this is to get a ruler, if you don't have a throw gauge, and to just see how much they're moving by holding this up to the side here. So if I put this, that's moving about 2 centimeters from the very tip of the elevator here. If I hold this here, and that's moving about 2 to 3 centimeters either side. So you got about 6 max centimeters of travel going either way. So yeah, that's about right for this plane. You want to have about 2 centimeters either way of travel, or perhaps an inch at most. If you want to change the amount of travel manually, you can change where the control rod is going into the control horn, into which hole it's going into. To give yourself the maximum amount of travel on your control surfaces, you can put the control rod through the outermost hole on the servo arms, and you can put the control rod on the innermost holes on the control horns. So this gives you the most extreme geometry on the control systems here. The opposite of this, of course, is to put the control rod through the innermost hole of the servo, and that gives you a little amount of travel on the control rod, and to put the control rod through the outermost hole on the control horn on the actual control surface itself. You can also potentially change the control travels on your transmitter if you have one with programming. This CXE, for instance, is a programmable radio that you program through an app, so that might be a good thing. And also you have a switch here for high and low rates. So you can actually just do that, and it limits the amount of travel that is transmitted through this to that. So that's pretty handy. Now again, just before you rush out to the field and try and teach yourself to fly, it might be worth considering that there are a lot of different ways to learn to fly that might not involve you just literally chucking the plane on your own and hoping for the best. One way is to join a flying club. Now there are lots of flying clubs all around the UK and all around the world, of course. In the UK, the BMFA website is a great way to find which local clubs are near to you. Another great way to learn to fly a model aeroplane is to use a flying simulator. You can get simulators that work with your computer, of course, but you can also get pretty good basic simulators that work on a phone. Although you're not using a proper controller, of course, you are using sort of the same thumb movements, and you are gaining a muscle memory, which will help you when you come to actually fly for real outside. Of course, they also have a reset button, which you don't get in real life, which means that if you crash, you can just start again. I really like using these, as it sort of teaches you new skills, and you can practice things even when the weather is rubbish, wherever you are as well. So yeah, I very much recommend getting one of those for free on the phone. Now before you go out to the field, you want to charge up your battery to full to make sure that you have a completely fresh 100% charged battery for your first flight. Make sure that you choose a nice calm day for your first flight. You really don't want to be fighting the wind, and yeah, so the less wind the better. Also, you want to make sure that the field that you choose is appropriate for the model that you're flying. Generally with your first flight, the bigger area the better, and the less obstacles the better, so the less trees. Also a nice thing to have is a field with long grass, so that can cushion your landings and your practice throws if you're going to do glide tests, which is something we'll talk about in a second. It does fall on you to be responsible as the pilot of a model aeroplane, so do choose a field that is appropriate. Make sure there aren't any houses, that there aren't any roads around, and there's not any people around either, which is obviously very important. Okay, that being said, let's go out to the field, let's go through some of the final pre-flight checks and get in the sky.
So I'm using this radio today, but you can use whatever radio that you have. So you've got your electronics installed inside, and if you've got your radio system all bound up beforehand, then you can plug your battery in and yeah, we can go through the pre-flights. We've got the transmitter turned on, and we're going to now plug the battery in. And those beeps indicate that the ESC is. Oops. Those beeps indicate that the ESC is now calibrated, so it's all ready to control the motor. It's got the high and low stops set up in terms of like how much the throttle will move backwards and forwards. So yeah, that's all happy. Those beeps mean it's happy. You just tuck the wires away in this hole here if you want to, and then you can position your battery on the Velcro, which is underneath the main pod or the main core section of the fuselage structure. So there is quite a lot of room here, and that's the reason for that is so that you can slide the battery backwards and forwards if you need to adjust the there's a dog coming. The reason there's a lot of room here is so that you can slide the battery forwards or backwards to get your balance set up right. I've got the plane plugged in, so that means the throttle is live. Now obviously propellers are dangerous. The throttle is right here. I've got my thumb over the top of it now just to make sure I don't accidentally bump it, because it's pointing towards my somewhere that I wouldn't want it to go into. So I'm going to put the transmitter down and just hold it like this, hold the plane under the main spar. And if you see here, I'm putting my fingers on just where the main spar is in the wing. You can feel it through the fabric or the covering on the wings. And I can see that it's pretty much sort of neutral as I hold it like that. And I can tell that the tail is dipping slightly, so what I might do is just move the battery slightly further forward like that. And that means that when I hold it again, there's more weight towards the nose, and therefore it'll line up a bit more neutral. If you want to err on the side of caution, then try and make it more nose heavy and tail heavy. So now we've got the balance correct. Now we need to check our controls. So as I put the transmitter over the top of the plane, what I'm going to do is imagine that this is a full-scale aeroplane and that this is the joystick that's inside the aircraft. So as with a real plane, if you were to grab the joystick and pull it towards your stomach, the tail should come up, and that's how you pitch the plane up. So you're going to pull back and the tail will come up as well. With the rudder, this is quite simple. If you bang it over to the left, the tail should go over to the left. If you go to the right, it should go over to the right. So yes, that's fairly straightforward. Setting up your controls with the right directions, again, like the centre of gravity, is absolutely key. So make sure that you understand this and that you get it right before your first flight. Okay, I think that's pretty much it for setup. We've got the centre of gravity correct, we've got the battery in the right place, we've got all the controls working. Now we need to just give it its first flight.
Okay, we're just going to cut back here to the studio to sort of go through what you're going to be doing with your first flights. I've got this little free flight plane here to help me demonstrate. So this is like a proper pre-flight briefing. You might want to do a few glide tests before actually taking the plane up and doing some proper circuits. This is a great way to get used to the controls and also the motion of hand launching. Obviously this is something that you should be doing over like long grass, so if you have that. If you have a nice runway, you can do some little hop tests, but yeah, basically just some nice glide tests by launching the plane in front of you and controlling it into the ground will teach you how to land, how to flare the plane, and all of that good stuff. The next thing you can do is to take the plane, launch it, use a little bit of power, go about 20 meters or so in front of you, and then try and land the plane like that into the long grass again. Again, this is a good way to learn the basics of the controls, to see how they respond, how sensitive they are, and to sort of get used to that flaring maneuver. So when you come into land, you can use a bit more elevator to sort of bleed off the speed, to increase the lift, and to sort of stall the aeroplane just above the ground, so that then you can settle into the grass.
So just a nice slow toss like this. As the air going over the wing creates lift, we're going to feel it lighten in our hands, we can let go. And immediately we can put our hand on the right stick. Remember, this is the launching it on your own method. If you have a friend, yeah, probably use a friend for your first flight at least. Okay, ready?
When it comes down to your actual proper flight, when you're going to take off and sail away gracefully, you want to sort of repeat what you've already been doing with the the hand launches. But in this case, you're going to be powering out, keeping the power on, and climbing up to a safe altitude. What I mean by safe altitude is that you're so far above the ground that if you make a mistake, then you will be able to catch that mistake and make sure that you're not going to hit the ground.
Ready? Yeah. Right.
The ground is the #1 enemy of model aeroplanes, followed closely by trees, of course. The higher you are above the ground, the safer you will be, of course, whilst maintaining it in sight and not getting too far away that you can't see which orientation it is. When you're up at about 100 feet, you can roll the plane by using the rudder and bring the aircraft round in a turn. Then you can roll the plane back out again, continue in a straight line, and then roll it again, and then bring the nose round to another turn. And therefore you can create this nice circuit by repeating that of going around at this sort of fixed altitude. To control the plane so that you're turning it and maintaining this circuit, what you want to do is to use the rudder to kick the plane over to one side, and then use the elevator by pulling back to pull the nose around like this. To get out of this attitude of being rolled like this, you want to kick the rudder back over, and that will straighten the wings, and you can carry on in a straight line. And then, of course, repeat it when you get to the end of that straight line and bring the nose around again. The way that the rudder works to roll aeroplanes like this is that as it gets kicked over to the side, this wing here creates more lift than this wing, and that's because this wing has more of an angle of attack to the oncoming air than this wing, and therefore it will lift the plane around like this. When it comes to landing the plane, hopefully you'll have a bit of a feel for this if you've done the sort of the little hops. All this entails is bringing the plane round in the circuit, reducing the power, descending, and then flaring above the ground and sort of just mushing it into the ground. With the Cub, you don't really have to worry about stalling it, or at least stalling it in a catastrophic way where you'll spin out of the air and crash into the ground. The elevator is very mushy, I would describe it as, where you bring the elevator up, the plane will just sort of stay at a safe attitude and sort of mush through the air, and you can pretty much just land it like that. The worst that can happen is that you sort of bleed off too much airspeed just above the ground and then sort of plough into it. But the plane is pretty robust, so if you're over a field, a nice sort of long grass field, should be okay for another flight.
10 out of 10. Okay, thanks very much for watching this video. If you did like it, then make sure to watch many more of our videos here on YouTube, and we'll see you on the next one.